So keep it clean. The ice pile. So this is the stencils frame, which tape down. These again, stencils. See, it's got a very nice solder on there. So we're done with that. Now we bring in now we gotta sort out the number of components. So we'll start off with the main chip. We need 14 of these. These are 12 millimeters each, so 14 times 12 is 144 times plus 158, 172. So that was the HC-SR04A. So these are a really good buy. They're like some ridiculously low price at Harbor Freight. And they work great for this if you're half blind. I'll try not to get in the way of the camera. So, tweezers, components, these are 0603s. These are the smallest I do because I just can't really do smaller. hit these points. Okay, we're ready to bake. So, let's do some camera adjustment. Whoop. Over here, we have got a golden toaster oven. So these thermostats came in a pack of 5, so I installed all of them just because. We can put these in here. Okay. That's wrong. That's wrong. Yeah, here. I guess the wrong person idea. That's our life of the. That's our life of the. Yeah, that's our life of the. Yeah, that's why it's to the. I'll leave check our life of the. Oh, we've got these powers using. I don't know what process it's. No, you just. Okay, so one power. It's not. Okay, sorry. Here's like. Okay, sorry. I will start through the. No. Right. Okay. So 3 lights come on. That indicates that all 3 elements are working. There's the 2 original elements from the toaster oven, and then there's the additional one added underneath. The whole toaster oven is lined with gold sticky tape. It is actually gold lined. Keep the heat in, and there's insulation packed in around the heating chamber to try and stabilize the heat in there. And we're trying to get up here to 200 plus centigrade, so this will take a while. So the Controlio people make a module with their stuff in it. I'm using their software slightly modified because I figured it'd be fun just to build my own controller. Yeah, it was an interesting exercise. Just go buy their controller. They have a newer version now. Now it gets into the flashing lights is a PID control, so it's getting towards its pre-soak temperature, and it has a profile it's trying to follow. So if all of them were on at once, it would be heating up too quickly. So it started to cycle through these on a very slow PID control. Now we're into the reflow stage, which is where it's going to bring it up to the temperature to melt the solder. So if we go into super zoom mode and put the light on, we should be able to actually see what's going on with our boards. There we go. Let's see. So you can see the solder is still very much gray. Hopefully this won't melt my phone. We're outside here. I've got my fingers outside, and on the far side of certainly the gold tape, I am not burning my fingers. But yeah, I think we're okay. Camera on my phone might be getting a bit toasty because it's there's a little space in the tape for peeking in. But hey, it's insured. Oh, that's a better view. There we go. Yeah, so we should be able to see the solder flash over. There it goes. There, it's flashed over, and that's at 236 on the temperature, which is a bit higher than it's supposed to be. So I have adjusted this up slightly because I think the readings are slightly off from reality, so I tweaked it up a little bit until it works right. But there, the solder's flashed over, and it's staying at this for, let's come out a little bit. Yeah, it stays at this for a certain amount of time. There's a countdown, I think it's 60 seconds. It might be less. So it stays up here. It's doesn't have the heaters on at all. It's just because it's at temperature. It's probably a little bit over temperature. And cool open. And then we have the solenoid that is supposed to push it open, but it also sometimes causes the thing to flash. But I'll take it the rest of the way out. We have a bit of smoke here. We are got the door open, so we're fine. And then we just wait for it to cool down. When it gets down to 100 degrees, it will tell me these are okay to pick up, but at 100 degrees they're still kind of painful to pick up, so I leave them a bit longer. So we'll come back when it's done. So this here is my test jig for the Octosonar version 3. You can see it's made up from two spare boards with a shield, standard shield on an Arduino, and a bunch of these pogo pins that will connect to all the different terminals that we care about. And also some of the pins are, how does this work? Yeah. So this will check the circuit for everything that's coming in and out of the board, and it runs through a little routine which will test all of that. So we just plug that in. Usually I do this over at my electronics bench, so things are a bit topsy. Because we have this text output here from the tool. So it's looking for an Octosonar, and when I stick one on the test jig, found the test jig. Let's give it a reset. Okay. Sometimes it's a bit fiddly. It's definitely fiddly while holding the camera here. Yeah, this serial is locked up. There it is, found test jig. So it's looking for an Octosonar. It's not finding one. Is this the old test jig? This may be for the old test jig for the V1. May have the wrong... No, it should be the right software because this is built into the test jig. Gonna pause and figure this out, come back. Yeah, I forgot. These get put on the other way up, so when I put it on we get a pass. So let's put the camera back. It's looking for an Octosonar. We push it down, the light goes out, it goes green, we're good. Now if it fails, there's a bunch of detail it will provide about the failure, and it'll cycle through every few seconds. So that guy's good, so I can put him to one side. We just go through them. Green. Oh, a failure. Let's try that again. Might just be bad contact. Okay, so that one says... That one says error 1 IC trigs F9. So I'm going to ignore that one. Put him over there. That one passed. So I was having a third party manufacturing these. I'd run them through this jig when I get them back from the people that are making them. So they all succeeded except this one. We'll try it again. And it's consistent. It consistently fails. So I get out the optivisors and have a good stare at it. See what's wrong. Ah, there we go. It has. Let's see if we can see this here. Yeah, we got a bridge in the solder there, so there was a little bit too much solder there, and it managed to come up with a bridge. So we can fix that in very quickly with the soldering iron. Just give it a little bit of... flux. We should just be able to remelt that, that'll be fine. So the software that does the bench test is designed to catch exactly this kind of thing, which happens extremely rarely. There we go. That's all it took. So, stick it down there. Green. And then, of course, now we've got things covered in flux. Okay, so made up some labels. Label. Okay, so that is 14 Octosonars made. We have still to do update the stock in Etsy, update the stock in Tindie, and do the inventory control for the accounting software so I can keep track of how many bits I've got to make things and how much it actually costs to make these. And that'll spit out a, why do I have one left? That's never a good sign. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One of them's gone walkabout. Probably over there. That's why counting things out every time is good, because you can find that you did something stupid, like when I was making up the labels, I took this over to the other bench to make up the labels, and I wanted to check the version number on the board. So I grabbed one of these and it was sitting on the keyboard over there. Okay, now we are done, and now we just need to do inventory control, and I'll take another 20 minutes and we'll be good. All done.